Uh, Welcome to our Silicon Valley seminar series. I'm very yeah, happy to be able to introduce you our speaker for this week. And also I encourage you all to come make this a regular thing. We have another speaker next week, and I have a very illustrious guy who helped invent the internet way back when, in about a month's time, Fred Baker, who is in the IETF, Internet Engineering Task Force. And I have a DARPA program manager coming in a little later this semester. So it's a good way to sort of get ideas, spur thoughts. So this week, we have Denny Luan, who is a co-founder of a company called Experiment.com. And basically, Denny was a student at University of Washington in, what was it, synthetic biology? Is that this in the field? And he and his other co-founder we're working on in a lab where if you ever heard of the Fold It program, this is a protein folding program which allowed people to sort of break down this really complicated problem among lots and lots of computers on the internet to solve or make a lot of progress on that. So that was the lab where Denny was a student. And I'm not going to steal all your stories, but basically how this whole company came about came from his or their frustration of being able to explore ideas as students, not wanting to write a huge, 50-page proposal, and you don't have all the connections with NSF or whatever. There's this big barrier between just a small idea and one of these colossal proposals that you really have to have a lot of experience to write if you want to be successful. So what can fill that gap? And that's where they sort of happened upon or decided to try out this whole idea of crowdfunding for science. So they were a Y Combinator recipient. If you know of Y Combinator, it's one of the startup incubator sites, which is kind of what brought them down here from Seattle. And they've been going strong ever since. So with that, I will let Denny tell you the story of Experiment.com.
Do I need a microphone? Okay, this will do. All right. Cool. Everyone can hear me now. All right. So this is just to make sure everyone can see the slides. Okay. Welcome. Hi, everyone. My name is Denny. This is me. My Twitter handle is Denny Luan, so you can follow me there. And this is my co-founder. Together, Cindy and I started this thing called Experiment.com. I figure most people here are either interested in the research side of things or the tech startup side of things. This talk, hopefully, my goal was just to introduce science crowdfunding as a tool for research. But in the end, if you guys want to ask questions about like going through Y Combinator or startups in general, totally happy to talk about that as well. But for the most part, we will talk about how to do experiments in science. So if you're familiar with Experiment.com, Experiment helps researchers by connecting them with funders directly around the world, and it looks a little bit like this. So this is what the website looks like. This is a typical project on Experiment. This is a real one. If you guys, you might not know about this, but this cat right here is like an internet celebrity cat. His name is Lobub. Actually, it's a girl. Who was born with a few like genetic mutations that make her have like shorter like bone structure and like a shorter snout. So she looks really cute, but no one really knows why. And so a bunch of genome scientists in Berlin, these are the actual guys, had this idea to what if we sequenced her genome and figured out what exactly it was that caused this, like the way she looks, the cat. And then we also crowdfunded it, and we got like Lobub's community and the fans involved, not only as a way to help support the research, but to help explain what actually goes on with, the science behind this. And so over 300 people, I think, came together to fund this project. This was not that long ago. So this is a typical like use of an application of crowdfunding for science. I guess I can give a little bit of background about Experiment. So we started in 2012. One thing I should note is that my background was in science, but I actually wasn't that good at science. I came from synthetic biology doing like bench wet lab work. But the entire time I was on this track for like finishing grad school, do this indefinite postdoc, hopefully one day become a professor, this set academic path. I felt like I was supposed to be looking for this like project, or supposed to be looking for my way that I'm going to make a dent on science. And the whole system today doesn't really help young scientists like find this track or discover it for yourself. So really what I was looking for, searching for, was impact. So first, let's talk about science. So this is what the academic kind of system looks like as a young scientist today. It's this very convoluted mess of you have this idea, you approach this really outdated web portal for grant funding, and then there's some abstracted process for how you get your funding. Eventually, once you're able to do the research and you try to share it with other people, which is the point of science, it has to go through these many layers, and hopefully that output is being read by the general public, which is then influencing administrators, yada yada. Why can't science look like this? A more direct connection with you and the public. The interesting angle that I like to talk about is that the powers that be kind of insist that this is how science is supposed to work. And while it's true there are certain checks and balances with the process, there's very little agency for scientists in this process. Like, you are just one piece in this cog, which is all kind of built on rent-seeking and making sure the system works, right? Part of this is with like open access. You see this today. Different ways of how you collaborate. But the other important thing is, by the time your research gets to the end, the general public, it's hardly recognizable because it's gone through so many different layers. And so we wonder why we have this like science literacy problem. Like, what is the research that you do today, and how does it impact an end person? So this system doesn't help you for that. The other thing that this system is bad for is that as a young scientist, when you're like just starting off this PhD program, or you're just looking for a project, it feels like this. Like you're staring into this long dark tunnel, and you can barely make out the shapes of people who are kind of in this process, and you don't really know like how you're going to get there. But the biggest question that a lot of young scientists and myself that I constantly was feeling was how does this lead me toward like doing a research project that actually matters? How does this lead me to impact? The other kind of big problem with how scientists connect with science impact today is they think that this is what's required to do impactful science. The problem in the last 30 years at some point was that big money got conflated with doing good science. And we, as scientists, I think generally, that's not always the case. In fact, sometimes big money can also get in the way of doing good science. A recent study out of Canada discovered that there's actually like an inverse proportional law, so that when you increase the funding for a research project, the return on your science investment actually goes down. So it's kind of led us to this idea for a lot of the general public, but even for a lot of scientists today, that your conception of what is required to do meaningful science is this abstract notion of things, that resources that you have to have, or expertise that you're required to have in order to deliver meaningful science. But what we need to remind ourselves of is that really all that's needed is just a willingness to explore and be curious and to pursue interesting research topics. And so if you can kind of hold on to that nugget, that's one of the questions that I want to lead you towards. But the other more important thing that I want to bring up is that the cost of science today are going down dramatically. So this is something that comes from my field. The cost of sequencing a genome in the last several decades has well surpassed Moore's law. This is relevant for my area of research because this means like my advisors and professors that I work with, there are problems and research opportunities today that they could never dream of, because suddenly there's so much more that's been enabled that you can pursue and ask. And so obviously as technology is spreading towards other areas of research, whether it's from geology to social science and particularly like engineering and hardware, there are going to always be more questions that you can ask that others haven't thought about. So recap, experiment is for doing science. It's also a way for people to fund science and ultimately sharing those results. That's what backers on experiment receive in return. And the questions that I would like, hopefully, you guys to ask is, can science be more direct? What does independence mean for a scientist today? And what makes a great experiment worth pursuing? So very quickly, also, I want to talk about transparency. Science today has an issue with transparency. It's not that scientists don't like transparency, don't want to be transparent. It's that the system today doesn't reward your effort. purpose for transparency. So there's an author named Michael Nielsen who wrote this book called Reinventing Discovery, who basically in it talks about how our value system in academia today doesn't actually reward your efforts or do anything to recognize beyond like choosing to publish in an open access journal or make your data set openly available or collaborate in an open way. Instead, if you're a young scientist and you kind of take that initial leap of faith, you kind of get a pat on the back, but nothing in the system kind of changes. And so for the first time, this is actually changing because with crowdfunding, your direct effort in being open and sharing and collaborating can reward you with a larger audience and more funding for your research. So let's talk about crowdfunding. What is crowdfunding? It is publicly funded research. Is anyone familiar with like the history of like Galileo? This is just a snippet I'll add in. So Galileo was, guy who discovered the moons of Jupiter and invented the telescope, but he was supported directly through, at the time, was a small like collection of people in like ancient Italy. So it was the Duke of Medici who funded his research directly, and in return he was receiving like the progress and the updates and the results of Galileo's research. So it's kind of, I bring this up because science actually has its roots in direct connection with funders and individuals. And so in terms of experiment, so what has crowdfunding has done for us so far since we've started? We've had over $5.2 million have been pledged to the site. We've had close to 400 projects have been funded, as well as we have over 40,000 members that are funding projects, creating projects, asking questions, engaging with actual science on the internet. And I should mention that of the projects that are getting funded and launching, the success rate of getting funded on experiment is 47%. So that's close to twice as high as NSF today. So this is just a short, just to show you guys our progress since we've started. So this is the total pledge volume that we've helped to facilitate every year. So another way to think about this is that every 2 days a new project on experiment gets funded, and these are projects ranging from astrophysics to social science. And then every minute that goes by, another $2 goes directly to scientists, like directly to a researcher on experiment. So I know that pales in comparison to like tax dollars and et cetera, but this is actual individuals, being motivated and take the initiative to go seek out curious projects and support them and be a part of it and engage with the science. Another much more important way I think about our impact so far is in actual scientific outputs. So since we've started, we've had 31 peer-reviewed publications that have come out of funded experiments. So these are in like academic journals, as well as like over 120 conference talks. One of the features we have on the site is in return for funding projects, researchers are posting updates. So we call these lab notes of basically data and images from the field and videos from the lab, preprints, and et cetera. So we've had over 4,000 of these have been published. And then for every funded project, we also issue them DOIs. So these are basically little identifiers that make them citable and archivable in libraries around the world. So we've already had some experiments have been cited in literature by ongoing research projects. So that for me is really cool. Another way to think about this is just looking at the cost of what it takes to like produce a paper. On experiment, with the 31 papers that we've had, this is the funding that's been raised by those projects. It basically comes out to like $5,000 per peer-reviewed article on experiment. So that's pretty neat. And this is similar for like academic talks, so conference talks and academic posters. Not included in this is like grad student theses, etc. But by some estimates, it currently costs the NIH and NSF today around $60,000 to $100,000 per peer-reviewed paper, and this is in direct costs, so not including like the cost of a university and etc. And so this means that with experiment and through this tool, you can deliver much more impact. Even if you're just looking at science output as like papers, which is just one way to cut it. So what does this mean for you as a scientist? This means that this is leverage, right? So ultimately, as a scientist, how you spend your time and what you spend your time investigating is the most valuable thing. And so this can be an important weapon or a tool to have in your back pocket that goes beyond just putting all your eggs in one basket when it comes to deciding what you work on and how it gets funded and how you share that. So an example, a real world example. So this is another project that was funded. This guy in the purple hat is a professor at the University of Washington. This project was especially awesome because this was about a year and a half ago. There was a proposed coal transportation line that would basically put coal in these open train containers from like Vancouver through a lot of industrial, residential, and commercial areas. And so it was a hot, contentious topic. There wasn't a lot of data, and so this atmospheric scientist decided, well, let's just like set up some air pollution measuring equipment and let's gather some data. And once the community caught wind of it, the local community, it like was put on some blogs and some newspapers. It got funded in less than a week. And he's actually since come back and run 3 more campaigns. So in total, he's raised around $70,000 just through real people. But the more important thing was the actual results and the data came out in this journal article, which he published in the Journal of Atmospheric Pollution Research. And they took this to lawmakers to actually influence the outcome. So you're kind of short-circuiting this entire that convoluted map of how science works into something much more direct. Yeah.
We talk about time frame. In other words, if you put a proposal to NSF and all that, compared to this.
Yeah. So if you guys aren't familiar, most NSF grants or NIH grants, like traditional funding, can take several months to apply and get feedback, and oftentimes there's several rounds of that. With Experiment, it takes probably a week to put together a project campaign, and then these campaigns run for 30 days where they basically kind of spread word and then get support directly from people. And then this paper came out like less than 6 months after it was funded. But that's just one example. So as a scientist or as a researcher, you might be thinking, this sounds really cool, but this requires me to talk to people, and I'm a scientist, and I got into science to avoid talking to people. That might be fine and true. The thing is, a lot of the biggest mental obstacle is thinking like, well, I'm not good at talking to people or talking about science, so how do I do this? It takes practice. So these guys practice a lot. I'm used to giving this talk to lots of grad students, so this, obviously, like you probably recognize these guys as like, this is Carl Sagan and Neil deGrasse Tyson, but this is what they looked like when they were our age, thinking about the same question of like, how do I get good? And it just so happened that these guys tried hard enough or practiced enough that now we recognize them as these guys. But the point is that it takes a lot of work to put your science out there. You might also be thinking this requires me to use the internet. I'm at CMU. I shouldn't really need to say this, but for other scientists, it should be said. So the internet and science go well together. Today, there's so many tools on the internet that make science easier and better. These are just a few that I wanted to highlight. You might also be thinking, well, no one will care about my work. Like, I'm a researcher, I'm working on something that's really technical, or maybe it's not seen as like a popular topic. Will anyone care or be responsive? And so this is a great segue, because the question that I usually respond with is, do you care about your research? Like, why do you care? Why is it that you've decided to devote 40 years of your life studying this one tiny bug that only lives in one area of the world? You're either slightly crazy or there's something about it that you see that others don't. And is that something worth sharing? So this is the good part, how to experiment, so how to actually use the site. So it's pretty straightforward. Through experiment.com, we have this platform that lets you create projects. There you're able to upload like as much content as you want, the context, the background, your research collaborators, your team, your experience, basically putting your science out there. Once you actually launch the campaign, then there's there's obviously work in spreading the word and putting your science in front of other people who would want to support it and be a part of it. And then in return for people funding the project and supporting it, you give directly back the results, the outcomes. So either you're answering these questions or you're sharing this process, giving them a window into what it's really like to pursue this research. So like right now, you can go to experiment.com/start. You can click start. So one thing that's worth mentioning is currently, so our team actually reviews every single proposal. This is not sort of any qualitative peer review yet, although this is something we would like to do, although our team does all have science backgrounds. But the criteria we use are very basic, kind of typical funding body like review criteria. So is it actually research? So it's not, you're not raising capital for a startup, you're not teaching a class, but it's an actual research project that's driving the project. Are you real? So we do vet the identity of these researchers, whether it's like university web pages, but also making sure that we can pay out the funds directly to either an individual or a university. And then can you meet the goals? So not that the goals are so lofty as like we're going to go to the moon, but also that you have the right experience or the resources or the expertise to meet the goals that you've set. So these are very basic criteria that our team looks at. And if it passes this, then we say, all right, now we can let the crowd decide. So some tips and pointers, having seen probably 1,000 projects from all kinds of categories and funded half of those. These are things that we often give back to researchers if you're thinking about this. One of the things that you should definitely do is plan and get feedback early. So this is one of those things where the more preparation you do up front, thinking about like, who am I going to share this with, or what is the message of my research, the more fun this process gets. So most people think about crowdfunding as like the really big Kickstarter campaigns that end up on TV stations and radio. You hear about it in the radio. That only happens because of all of the like forethought that people have put into it, thinking about how am I going to get to certain audiences beforehand. So one way to think about this is a chart of all of our funded projects below $20,000. And so on the bottom you have backers, and on the left you have the funding raised. And so this slope, this line, this blue line, kind of represents the average pledge. So this is how many backers per project with total funding. And so you'll find that the average pledge is around $53 for this data set, and it's pretty close to the entire site. So that's one way to think about, like, if I'm going to do, I need $5,000 for this piece of equipment, which will help me finish my graduate thesis. How many people do I need to reach out to support this? This is kind of one benchmarking for that. Another way to think about it is if you look at number of page views. So getting people to see your science and see your project, how do you get those eyeballs? This is the same data set. Unfortunately, there's a few outliers that makes it a little bit less of a good fit, but the slope actually stays the same. So this green line represents each page view that you get on your experiment project brings about 25 cents. So if you're thinking like, same thing, I need to raise $5,000, you can kind of look at how many page views you could expect to get. We do have all of this data online at this link. If you would like to see this data set, you can just message me after or ask me. So another thing, do find new and existing audiences. This is something that a lot of scientists don't always actively think about, is who are the people that would really love my research, and where do those people live? And one of our core beliefs is that for all science on the internet, there is a group somewhere out there on the internet that would love it. It's just, this is the coordination problem of how do you connect the provider of this awesome research and the people who would want to support it. So there's an audience everywhere. One way to think about this is that right out of the gate, every project on experiment has a 46% success rate. But this actually changes the closer you get to your funding target. So this graph shows as you get closer to meeting like your funding goal, how likely it is that you're going to succeed. And so this graph kind of demonstrates social proof. The idea that if people go to a project that's at like 10% funded, are they less likely to support it if it's at 90%? So you can see just getting to 40% of your funding goal bumps up your chances to almost 90%. So it's pretty significant social proof in action. Some don'ts. So some tips about what not to do if you're thinking about approaching the internet to support and engage with your research. Don't treat it like a grant. A lot of researchers sometimes think that if I just create this thing, then the money will appear and show up. Money does not just appear, unlike a grant. But unlike a grant, and a bit more of a refreshing state, is that you are actually in control of the success or the outcomes of your funding situation. So for every tweet or every share or every email or every interview you do, that directly translates into backers and page views. And so it puts you in the driver's seat as opposed to this kind of abstracted process of where you never get feedback, you never know the outcomes, you don't see what happens. This is actually it's something new. And obviously, of course, we have tools. So this is a dashboard that all experimenters have. So for every tweet or page view, we show you where those people come from, where your backers come from, and this is constantly improving. And then the last thing is don't treat it like you're begging for money. So this is particularly for some researchers a reason to hesitate, thinking is it weird that I'm asking for a handout for my research? Would I stoop so low to do that? But also, what does that mean? That's kind of one thing that frequently comes up. And so what we always encourage researchers to say instead is to try to think about it as you're inviting the public or this larger audience of people who don't know about this into this awesome opportunity, this awesome chance that they would never otherwise have. Really, the best way to think about it is, as a scientist, you are a gatekeeper to new knowledge. And no one else is really going to go through this door unless you're motivated enough to share it, do it. And so if you could just frame it that way, suddenly it changes the dynamic of, will you please fund my project or support it, versus, do you want to join me on this awesome discovery where, well, who knows what we'll find. So as scientists, you hold the key to knowledge. This talk is kind of accelerated, so I just want to end with what's next and what would come next for experiments. So pretty shortly, we're going to be launching peer review. At this point, we've had close to 700 projects or researchers who've been funded who are not only experts in their area of research, but also experts in science communication. And so this will be something that we'll be adding as our community is able to help support and vet and provide feedback for the projects. We're also launching a new grants program pretty soon. We'll be pairing with specific funders around very specific topics. So the first one we're doing is actually marine mammal research, which I don't think anyone here does. But we might do like artificial intelligence research pretty soon, and that would be a good way to like kind of jump in if you're thinking about it. Tax deductible. So currently, pledges on experiment are tax deductible if we work with the university. It's not the case for all projects that launch, but this is something that we're working on, and we should have this up and running pretty soon as well. And then the last thing that we're going to be doing that is worth bringing up is science publishing. So for the researchers who are sharing their content on experiment and all of the process and the output, we've actually launched a new publishing platform as well for these researchers to basically share a long-form version to like lay people what the results and outcomes have been. And so on top of this is obviously thinking about, well, what about the metadata of all this content that would suddenly be living on experiment, and then building on top of that a layer of impact. So giving funders a way to see, not necessarily like a citation rating, but a way to see like, the projects that you funded have generated this many page views from around the world, and how does that impact your behavior as a funder. So this is a screenshot. It's actually live right now at experiment.com/journal, where we've been publishing these kind of really awesome articles about the results of these projects. So this is, I just want to end with a few examples. So this is an example that I quickly added in. It was actually a computer science graduate student at the University of Washington. Her part-time hobby was doing stand-up comedy, so she figured, what if I did this project basically trying to write an algorithm that could create jokes? Because jokes really are just this structured thing of, you set up expectations and then you say something funny that breaks those expectations. So could you use natural language processing to kind of develop and create jokes on the fly? And so this was actually our second project that ever got funded. So this is relevant, hopefully, to you guys. Something that's more recent. So this is a project actually based out of Berkeley, Oakland. It's a DIY biohacker space called Counterculture Labs. It's a bunch of researchers who've come together, and they're developing an open source protocol for insulin. So today there's no cheap generic version of insulin that you can buy. So if you're diabetic, you have to kind of go through this very expensive version. And so these guys are basically tackling the biochemistry challenge and then making this open source protocol so that hopefully one day you could grow insulin, at home for use by yourself. But that's kind of the big goal. The first goal is making the protocol known. So taking away the power from big pharmaceutical companies that hold all the IP. And so this project was funded pretty recently. And another one that also shows kind of the impact. So since 1998, there's been a federal research ban on anything related to gun control. And so we had our researcher, this was probably a few years ago, who wanted to look at a CDC data set of teen gun violence and correlate it with local state gun laws. And so because of that gun ban, this researcher literally had nowhere to turn to do this research, and so crowdfunded it to be able to support a grad student and then look at that data. So this is the type of research that you can do that you can't do today because it's deemed unfundable or too risky or doesn't fall into a typical bucket. So just wanted to end before we get into questions. This isn't about funding. This is about scientific independence. This is about giving agency back to researchers. And so usually I end with this cheesy quote, this like Marxist quote, which is like, scientists of the world, you have nothing to lose but your chains and a world to gain. So world where anyone can be a scientist. So that's our ultimate goal, what we'd like to do. So thanks, and Obviously, questions about how crowdfunding works and experiment.com, but also general questions about startups and things like Y Combinator, how we got started. Happy to talk about any of that. Yeah.
As an engineer, I'm kind of curious what the scope is of what kinds of things experiment funds. Does it fund engineering projects if I wanted to build something, new capability?
Yeah, so we have right now on the site, I think, 22 categories. And one of the categories of research is actually engineering. So, for example, we've had most universities have Formula SAE teams, which are these like mechanical engineering student-led like race car teams that compete. So we've actually funded like 6 of those on experiment.com. As well, we had 3 high school sisters created a hydroponic garden and have sent it to the International Space Station. That kind of falls under engineering. So they raised $20,000. So it really is anything that is like you're asking a question and you have a hypothesis and you want to test it. Yeah. Yeah. So the question was, is there any sort of legal obligation around sharing content or sharing data that might be sensitive, or if you intend to publish, for example? That's another common scenario. Because we process these funds as gifts, typically to universities, there's no strings attached. So legally, we can't require anything. We just gently encourage you to update and be transparent. Because really, that's the spirit of Experiment, and what makes the whole site work is this willingness to share and kind of engaging directly with your funders. So, yeah.
I'm trying to think about ways this could backfire, but if you're talking about how the funders would really feel involved sort of along with the researcher, have you had situations where the funders feel entitled to not only ask questions, but maybe even say, well, I think you should do it this way, or why don't you do this other thing, and sort of get in the way of perhaps the original idea?
So the question was, can funders ever have adverse effects, or are there adverse effects to taking funding from a large group of, to be honest, unknown people initially? So we actually have had some instances where we had like a breast cancer project that was live, and then one of the funders came out and said, I'm also a breast cancer researcher. Like, why are you doing this protocol? Have you thought about this, this, and this? And this was like an open discussion. And suddenly the researcher came out and responded, and there's like an honest, open conversation about the methods and the protocols. And that's what we want more of. We've never had an instance where that turned out badly, but maybe it's just a matter of time. We have had projects, so citizen science is another big focal point for us. So we've had projects where the backers are also contributing data or getting involved with the actual data collection. So an example of one of the biggest projects we've recently funded, there's a group of researchers who are testing if animals can tell the difference between GMO corn and non-GMO corn. So they basically ordered like several tons of Monsanto corn, and they mailed it to all of the 300 backers around the country. And they put it up in their backyards, and they're gathering the data and sending the data to the researchers. And so the researchers are going to be working with a bunch of statisticians to process the data, and just add another data point to this whole debate about GMO crops. Yeah.
About the mechanics of the grant, that is, the university takes an overhead, for example. So if you raise a certain amount of money, then the expectation is that some amount is going to get lopped off the top. And is this kind of built in, or does the proposer have to build that into their request?
Yeah, so the way that we transfer funds to universities, we actually avoid indirect costs. So most grants, when you accept a grant from like NIH, a university will take 50% of it, often sometimes like 90% of it, just away as indirect costs. So because we process it as a gift, it's considered basically university can't take costs. And so it's also processed much faster. So that means it ends up in like a budget account within a few days.
People here take 12%.
Ah, okay. Yeah, so that's something that's pretty important to us because the researchers are the one actually engaging with the public and raising the funds. They should be the ones that receive all of it, as opposed to the university just taking 50% of it right away. Yeah.
Actually, I'm curious about how you attract the backers and what the backers can get from funding others. Because, if I'm a backer, I want to invest in something, I may go to Kickstarter because they have some, everyday life things. They have some, maybe their products, I want to use their products, so I want to fund them. But for this one, for this scientific research, what can I get?
Yeah, so that is a good question. With Kickstarter, so the natural output of the creative process is like a product. It's like a DVD or a T-shirt. The natural output of the scientific process is usually just more science, or like more questions or more projects. And so what we've built with Experiment and our platform, so all of it, we've built like the content platform and everything ourselves. We're really trying to deliver is like this rewarding sense of funding science, but also being a part of the research. And so backers of these projects are, they're getting all of the data and the direct answers directly from scientists. So they're asking questions and they're meeting them, but they're also, getting put in the footers of all of these published papers. And that's a very tangible way to see your impact on science. But beyond that, I think it's just the community interaction that's currently what's driving a lot of the backers. And so in terms of who these backers are, it's funny. So Tim Berners-Lee, another guy who made the internet, is one of our backers. He recently supported our project. We've had, one of the founders of Twitter backed his alma maters recently, one of the big projects there. Backers really come from everywhere, from all over the internet. A lot of it is social media like Twitter and Facebook. But a lot of it are also just people who are interested in science, or maybe were researchers in a past life, and like really want to know the answers to these questions. Yeah.
I think your project, like the experiments, they all have time limits, right? What if the experiment is not finished before that time? Will you refund the money?
Yeah, so experiments similar to Kickstarter in that it's all or nothing. So every project has a set deadline, usually 30 to 60 days, to basically meet this funding goal. That's actually more for motivating the researchers than for the backers, just to make sure that they're the ones doing the outreach. Because if you don't have a time limit, then it makes it harder for these projects to become fully funded. Oh. So once the researchers have the money, then it's basically all in their control. So there is no deadline for like when you have to deliver results, although that is an interesting idea. Maybe that's something that scientists may or may not respond well to. But basically it's like once the researchers have the funds, it's up to them how they can spend it. There's no like, you have to do what you said. You're flexible with how you use it. No, once the funds like get sent to university, it's basically in their control. Mm-hmm.
Do you like most automation is like that to make everyone a scientist? And but I always think the science is serious thing, and you put it on the like the crowdfunding. Do you think it will be less serious or?
Yeah, that's funny. So if I could, I would show you. So my co-founder Cindy, just like 2 days ago, she started this new project where she's running this experiment of what happens when you bake cookies from scratch, like if you freeze the butter versus if it's like room temperature before you make it, right? And so that's not like a super rigorous, like we're going to cure cancer, but it's applying the scientific method. It's a research project, and it's a project that others would want to see the results of. So she somehow convinced a bunch of her friends that like who also bake a lot of cookies, they want to know, and she's going to test all of it, and she's shared her protocols, and like is going to be rigorous about the process. Does that still count as research? Yes. The only time we've had to turn down a project, so we had, for example, apparently there's a huge community for tracking Bigfoot in America. And so like every state has reported multiple hundred sightings of Bigfoot. And so that was the only time where we had to come in and say, like, although the process might be rigorous, we had to turn that one down. So that's the only time we've ever done that. Yeah, so around IP and patents, so particularly for like engineering projects, or if you're doing something that could be turned into a product, like I said, there's no obligation to share like the strict technical details. But oftentimes for backers who want to connect with the project, that's not even what they're going to be looking for. Like they might not want to see all of the real technical details to understand like what is the meaning and impact of the stuff that I funded. So that's part of it is like there's no obligation to do that. And so ultimately it's up to the researcher to decide like what are you comfortable sharing in terms of like, am I going to publish this later or would I patent it later?
Aside from trying to research a new like, problem that researchers who have actually completed the project on their site or when there are large university labs and have street credit, squeeze out the new.
Yeah, so this is a great hypothetical that always comes up is like, if this is successful, does this turn science into a popularity contest, or are you just moving the problem area from one space to another? I mean, that would be a good problem to have. I'd love to see what happens when we get there. That's my cop-out answer. More realistically, I think in the end, because this is scientists directly interacting with the public, I think there's still always that element of control, as opposed to having these layers that go in between, like that decide whether or not this research should go on. And maybe it could become a popularity contest. Maybe it won't. I don't really have a good. I would rather not speculate on that at this time. Yeah.
Yeah. My interest is in machine learning, data analytics, and so forth. And one thing I've noticed is often let's call it the bottleneck or a problem area in the current funding model is the following. Often there's someone with a very intriguing, interesting data set that come from more the traditional science disciplines like bio, geo, planetary sciences, that stuff. Then there's someone with an interest in analyzing that data set. They might come from, let's say, computer science, computer engineering, math, statistics, whatnot. And marrying those two types of communities, the data-rich communities and the analytics communities, whoever belong to, I'm not sure who belongs where, could be potentially very interesting to me, because this is also an area where the traditional science agencies often fall short, because they're very hierarchical. They will either fund, the data guys, the geo guys, the bio guys, and then of course there's the analytics people. They will fund their own. They will fund the math people, they will fund the statistics people, they will fund the computer scientists, computer engineers, and the two shall never meet, right? It's not entirely true, I'm exaggerating here just to make a point, but I think that could be a quite exciting angle, if you will, for something like, experiment.com, to try to attack those weak, clear weaknesses. I mean, you mentioned quite a few already. Do you have any thoughts about that, or is that something you have already, addressed in some sense, or maybe you have seen some successes in this area?
So actually, this is why computer science. So computer science, when it comes to research funding, is a little bit of an outlier when it compares to the rest of academia, because the ties with industry and also sometimes how well supported younger researchers are. But this is exactly also where computer scientists can have a huge impact, or at least a bigger multiplier when it comes to being interdisciplinary. So interdisciplinary research is one of the hardest things to fund today through traditional funders. And it's funny because NASA actually just recently has created this open data portal. So like all of NASA's data from all of their satellites and buoys and everything is on the internet today, but no one's looking at it. But the people with the skills to look at it are like literally you guys, who could just like very quickly set up something that becomes a platform or becomes something that others can build off of. And oftentimes the big obstacles or the costs are just machine time, researcher time. And so those are things where crowdfunding can have a huge impact. Yeah.
Okay, very good. Thanks.
Cool.